Today we're going to be talking about the derivatives of the 6 trigonometric functions. So we're going to use the definition of the derivative to help us derive the derivative of y equals sine x. So remember, when I ask you to use the derivative, the limit as h goes to 0 of f of x plus h minus f of x all over h. So then I plug in my function. Now we have to use our sum and difference formulas to expand that sine of x plus h. So that sine of x cosine h plus cosine x sine h minus the sine of x all over h. So those identities that you learned last year are going to come in handy. Now, rearranging the top, we're going to gather together the first term and the last term over our common denominator. And then we have the middle term over our common denominator. Now, that first term we can factor out a sine of x, and we're left with cosine of h minus 1 all over h. Remembering your laws of limits, I can distribute that limit as h goes to 0 to the second set of terms, and notice what we have here. We have the cosine of x and one of those special trig limits I wanted you guys to remember. Sine of h over h. So now, changing this up a little bit, I'm going to take that sine of x and just leave it hanging out with the limit as h goes to 0. I'm going to multiply that to a limit h goes to 0, the cosine of h minus 1 all over h, and also doing the same thing because we do have a product rule for limits. Remember, we don't have a product rule for derivatives, but we do have a product rule for limits where I can distribute that limit to each term. Now, limit as h goes to 0 of sine of x. Well, that's just the sine of x. That's just standing for essentially a constant times, remember, this limit was 0. Limit as h goes to 0 of the cosine of x. Well, that's just the cosine of x. Remember, this limit went to 1 from the special limit laws for trig limits. So therefore, we know the derivative of sine is equal to the cosine of x. And that's by using our laws of limits. Now, I don't want you guys to have to do those laws of limits each time, but I think it's important for you guys to understand where we got these trig derivatives from. Here are the derivatives of the 6 trig functions, and please make sure you have these written down. These are ones that we're going to be using a lot of. Now, notice how the derivative of any cofunction is negative. And sine and cosine are kind of paired together. Their derivatives are essentially the opposite of each other, where the derivative of sine is the cosine, but also derivative of cosine is the negative sign. For tangent and cotangent, I kind of have those lined up together because each one of those has a squared to it. Just remember, co-derivatives are negative, and the co's also hang out together. Cotangent is cosecant. And tangent is just secant squared. And then secant is secant tangent, and cosecant is negative with the coversions. So please make sure you remember those. Please make sure you have those written down in your notes. Okay, find the derivative of that. Now we have a product rule in here because we have x squared, actually negative 4x squared times the cosine. So remember your product rule. I like to do the product rule where I take the derivative of the first, leave the second alone, plus, leaving the first alone, derivative of the second, well, that's negative sine of x. So our derivative is negative 8x cosine x plus 4x squared sine of x. I'm okay with you guys leaving it like that. If you want to factor out a 4x, you could. Sometimes factoring stuff out is going to help us get an identity. Not all the time, but sometimes it will. That didn't really help us at all. So either one of those would be okay. Just be prepared on a multiple choice question. They may ask you to do a little bit of factoring. Find the derivative. Okay, cosecant. First, see if you can simplify that. So cosecant x, cotangent x. Cosecant's 1 over sine, and cotangent is cosine over sine. If I were to simplify that, it would be more complicated than what I have because I would have a quotient rule. The quotient rule gets really complicated. So I'm going to leave it as a product rule. Again, we have cosecant of x, cotangent of x. So our derivative of cosecant, derivative of the first is negative cosecant x, cotangent x, times by this cotangent, because I leave the second function alone, plus, leaving the first alone, times the derivative of the second, well, that's a negative cosecant squared x. Now, I do want you to do some simplification here. We have negative cosecant x cotangent squared minus cosecant cubed x. Wonder if anything could happen if I factor out a negative cosecant. That's going to leave me with cotangent x squared plus cosecant squared x. Well, okay, let's remember our identities. The identity for cotangent squared and cosecant squared is 1 plus cotangent squared equals cosecant squared. So that I can't change this identity into something here and make it a little simpler. So that is what our derivative is, and I can't simplify it anymore. Our next derivative. Now sometimes it is going to help you to maneuver your original function. Cosecant or cosine times cosecant, which is 1 over sine. Well, cosine over sine is cotangent x. So we have cotangent x over 3 minus cosecant times cosine is cotangent. Now before you do anything else, before you start taking your derivative, look at what you have going on the top. You have a product rule on the top. So if you try and take the derivative of this, you do low, d high. When you start taking the derivative of this top, then you're going to have a product rule built into a quotient rule, and you're going to get confused. Trust me. I started to take the derivative of this without my little trick I'm going to show you in a minute, and it made my head hurt. So what I want you guys to do, what might get rid of the cotangent here and this cotangent here? What if I multiply the top and bottom by tangent of x? Now since on the top, since I'm all multiplication, I can just multiply the tangent times the cotangent, and we are just left with our top. Now when I distribute the tangent through, I get 3 tan x minus 1. Now that's going to be a lot easier derivative to take. So our derivative then, low d high minus high d low draw a line, square the below. Okay, so simplifying our derivative. If I were to FOIL out the top and just simplify, because I never know if I multiply something through, I might be able to simplify even more. I get 6x tan x minus 2x minus 3x squared secant squared x minus 3 secant squared x. I bet you guys are yelling at me because you caught what I did wrong. I forgot to square the below. That is probably one of my most common mistakes. I always forget to square the below. So keep that in mind and you don't make the same mistakes I make. Okay, so that made us, that multiplying by the tangent x over tangent x made this problem a lot easier. So keep that in mind when you're doing trig derivatives. That doing the simplifying a little bit first is going to help you. Next example. Write the equation of the line and normal to the line of our graph. So, okay, first let's evaluate the function at pi over 4 so I know what my y-coordinate is. When I evaluate, I find the tangent of negative pi over 4. And hopefully none of you are putting that in your calculator because we all know that that is negative root 2 over 2. So then I find my derivative to find my slope. Derivative of the tangent is the secant squared. I evaluate our derivative. The secant of negative pi over 4. I evaluate that first, then square it. When I evaluate that, I get 2. So our tangent line, y minus y1, which is root 2 over 2. It was negative, so it became a plus. Slope x minus our value, and I'm okay if you leave it like that. Now the normal line. Remember, normal uses the same point. That's why it's so easy. But what you want to think about, you do the opposite reciprocal of the slope because it's perpendicular to our tangent line. So our slope is negative 1/2. Okay, next, finding our second derivative. Remember this notation here means second derivative. So I find my first derivative. Okay, let's look at this. This first term is a product rule, so make sure you do your product rule. Derivative of the first, leave the second alone, times by leaving, or plus, leaving the first alone. derivative of the second. Don't forget your negative. I'm going to go through and erase my plus sign and make it a minus sign. And you might not even want to write a sign in there until you go through the whole problem. So derivative of the first, leaving the second alone, plus leaving the first alone, derivative of the second. Okay, so we're good there. Plus derivative now of that second term, derivative of sine is the cosine. Just look at that real quick, see if you can combine anything. We can't combine anything. So we go to y double prime. Now I have two product rules. This first term is a product rule. The second term is a product rule. So the first term, derivative of the first, leaving the second alone. I'm going to leave an open space in there. I know it's going to be a plus, but I might have a minus sign. Leaving the first alone, derivative of the second, I do minus sine of x. Okay, now, second one. What I'm going to do, since there's a minus sign out in front, I'm going to put in a parenthesis. Then I'm going to end up distributing that negative. So derivative of the first, leave the second alone, plus leaving the first alone, derivative of the second, well, derivative of sine is positive. And then we have our last term, derivative of cosine is the negative sine. So now, let's simplify and distribute everything through. Look and see real quick, is there any terms I can combine? Oh yeah, look, I can combine those second and third terms. You guys might see that right away. You would think I had my notes in front of me. I didn't see it right away until I just looked at it. So make sure you give me the most simplified version of our second derivative. Okay, simple harmonic motion. A weight hanging from a spring bobs up and down with a position, so it gives us the position function. What are its velocity and acceleration? So just to review, derivative of position is our velocity, derivative of sine is the cosine of t. And then acceleration, remember, is the second derivative of position, which is the derivative of velocity. Derivative of cosine is the negative sine of t. That's it for today. Please make sure your lesson summary is submitted on time.